Hello, everyone. Welcome to the App Modernization demonstration. My name is Hank Scorpio. I work for the Globex Corporation. I'm glad you could join me today. We are a global conglomerate. We have a retail business that is one of our key businesses to our overall strategy as a company. And I want to tell you a little bit about the history of one of the applications inside of our retail business. There's been a group of folks that have been knocking on my door, emailing me from the Konveyor community that wanted to hear about this and kind of our history of our retail application and where we are today. So I'm excited to invite them into the room here and into the meeting and tell them the history of this and see what they can do to help me modernize this application. So this retail application is a typical N-tier application. It started in the mid-2000s. It's a monolith. It runs on VMs today on VMware vSphere. We've got a number of challenges with this. Our code commits take a very long time. We had a code deployment that brought down the entire system once. When things fail, it often takes us hours to fix them. It's leading to long downtime. And during peak times, we have trouble handling transaction volume. So if you're familiar with the DevOps metrics that you want to measure, we're failing in all of them with this application in the mid-2000s. And so we decided to begin to strangle this monolith. There's 4 services we identified: the gateway service, the customer service, the order service, and the inventory service inside of this application. And so what we did is we began to strangle them. And at the time, we heard of this platform called Cloud Foundry. And so we decided to basically strangle out the gateway and order service and develop a new modern front end that would make our application more customer friendly as well. And we did this all on Cloud Foundry. We did it using Spring Boot. Unfortunately, we realized that Cloud Foundry is not the best choice of platform given the momentum that Kubernetes has in the ecosystem. So we now, we started to realize that we didn't want to develop any more applications on Cloud Foundry. And we also started to discover new runtimes like Quarkus that were even more efficient than Spring Boot for cloud native application development. So what we did next was we took this inventory service and we split it out into a Kubernetes environment. The nice thing here is that we could actually bring our database on Kubernetes because Kubernetes could handle persistence. We developed the inventory service using Quarkus, and we thought we were moving in the right direction. Unfortunately, the big challenge we have with our Kubernetes environment is that we've manually deployed this inventory service. Our development teams kind of have just developed it and have a manual way of deploying it. And in order for us to promote this into our production Kubernetes clusters, we're going to have to re-platform it. We're going to have to automate the way we do this. They're really trying to embrace a GitOps method for our development. And so they don't want to just have manual deployments. They want to be able to redeploy in an automated fashion. So this is where we are today. It's really challenging. Our customer service still remains on VMs. It's slowing our deployment frequency. So we still can't deploy any faster than we used to because our customer service is really lagging behind in the ability to deploy faster. Our services on Cloud Foundry need a path forward, and we need to move them to a platform that has a strong and reliable future. And our inventory service needs to be automated so that we can deploy it into our production Kubernetes environments in the future. And most of all, perhaps is that we're maintaining 3 platforms, and this becomes really difficult. You see one of our employees there who's having a tough time managing all 3 platforms at once. So I've invited the Konveyor team here because ultimately what I want to get to is this. I want all of my services running on Kubernetes so that I get the benefits of it: horizontal scaling, automated rollout and rollback, bin packing, all those great things that Kubernetes gives me. I want to leverage a GitOps model to decrease my lead time for change, mean time to recover and change failure rate, and increase my deployment frequency. And I want to simplify my operations by putting all of this on a single platform that's easier to manage for my ops teams. And then I can start to plug in cloud services and all these other things and do even more fancy cloud native things in the future with this application to increase its value. So I've invited the Konveyor team here. This is my current retail application. Ramon, you were telling me how you guys can help me start to modernize this app. Can you tell me more?
Yeah, of course. So first of all, I think we need to run an assessment on all the different services within your application. And it looks like this legacy customers component will be a bit problematic. So I think we should run an analysis on that one to try to find out what could prevent it from running on containers. And once we have found out everything, start with the refactoring of the application to adapt it to a more cloud-friendly architecture.
Nice. That's great. So once we do that, what am I going to do with this database, though? Miguel, you were telling me something.
Database, yeah. I mean, there are some workloads that are not intended to be migrated straight ahead, and that the modernization could take longer, but you could bring them to Kubernetes either way by moving them as virtual machines. So you just take the database in the virtual machine as it is. So you just deploy it as a virtual machine on the target, and then you could leverage all the features that Kubernetes provides for virtual machines because they are just another Kubernetes object.
Oh,
You'll see that it blends. It will blend a lot better in your CI/CD pipelines and in your GitOps.
Thanks, Miguel. Yeah, that's good because I'm scared to do anything with that database. It scares me to death to touch it. It's very old. What about my Cloud Foundry apps?
Yeah, so you can take all your Cloud Foundry apps and use the Konveyor MotoCube to analyze the code and create the right artifacts for deploying it into Kubernetes, including your CI/CD pipelines. Everything will be modernized with MotoCube.
Oh, wow. All right. Thanks, Ashok. And finally, my inventory service. What am I going to do here?
So for that, we'll use the Crane project, which will help you remove everything that was hard-coded in your deployments. And so we'll clean this up, push that to Git, and get this fully automated so that you can really deploy this app and promote it from dev to QE to production in an automated fashion.
Thanks, Marco. So we've got assess, analyze, refactor, rehost, replatform, all these things onto Kubernetes. I'll tell you what, I want to believe you all, but it sounds too good to be true. I think I need to see it to believe it. So maybe we can get started.
Okay, definitely. So allow me to start with the assessment of your portfolio with Tackle. So let me share my screen and pray to the Fedora gods that this works. It seems to be working.
Great.
Okay, so the entry point for the Tackle tool is the application inventory. And what we intend to do with the application inventory is offer organizations a way to manage their application portfolio and have a holistic view of this application portfolio. So it looks like your architects were proactive enough to load up your portfolio within the application inventory, so we can get started here. One of the cool things about the inventory is that it allows you to classify and manage your portfolio in any way you might want. First of all, we have the notion of business service. So right now we have all your different business service on screen, but we wanted to focus on your retail applications. So we can filter the retail applications just like this. And talking about managing the portfolio and classifying the applications, one of the most exciting features in the application inventory is an extensible tagging model that allows you to classify your portfolio in as many dimensions as you might want. So, for example, focusing on this legacy customer management application we were discussing before, if we expand, we can see a series of tags in here. For the moment, we have used the tags with the concept of technologies that each application has. So we have Java, Tomcat, Oracle. As I said, the tagging model is extensible. So we added another tag type related to the different custom frameworks you might be using within your application. So it seems like this legacy customer management application is using a custom configuration library. And I get the feeling that this might be the problem that we need to solve to make this application suitable for containers.
Yeah, no, that's great. It'd be great to look into that custom configuration and figure out more, learn more about it.
Okay, so let's start the assessment. So we can select the application and get straight away into the assessment. We already filled out the assessment beforehand. I know you're a very busy person, Mr. Scorpio, so I promise this will be fast.
Great.
So if we continue, the first thing that we are presented is the list of stakeholders that have been involved in the assessment. There's this Homer Simpson guy in here. I think you might be familiar with him.
Yeah, he was very involved in this application.
Okay, so moving on. Well, the way we see the assessment is a questionnaire-driven assessment. So we are presented with a series of questions of different aspects related to the application landscape. And by that, I mean technology, application lifecycle management, architecture, all the different concerns that might have an impact on the application. And the idea behind the assessment is to find out how suitable the application is for containers.
Okay, so this gives me kind of a general idea of what might be challenges that I might have in containerizing the customer service app.
Exactly.
This would have been really helpful with the rest of our services we strangled out. So it's good we have it now.
Yeah, absolutely. Happy to be here to help. So yeah, what the tool does is based on your answers, it detects a series of potential risks that might prevent the application or present some sort of threat for the application to run on containers. So let's skip the assessment and go straight into the review to find out what these risks are. So I can save and start with the review process. And here we have a high-level diagram of the different risks that have been identified out of my answers, but we can get down to the detail.
Yeah, we should check out that high and medium, I'm guessing, yeah?
Absolutely. So we have the list of risks identified. If I reorder this thing, I get the high and mediums presented first. So there seems to be some problem with the way your application handles service discovery, and that makes sense because it comes from a legacy platform in which static IPs and things like that are used, and that is not very cloud friendly. So that's one thing. The other risk that has been identified is the maturity level in your organization related to containerization process. But I guess that's why we're here.
Yeah, absolutely.
And finally, we have detected that you have some trouble with how the application is being configured. So there seems to be multiple configuration files in multiple file system locations, and that is an anti-pattern when you're talking about cloud native and cloud friendly applications.
Yeah, I seem to recall some developers had been loading configs from local file systems, so that makes sense.
Yeah, absolutely. So it seems like this custom library that we already detected has some sort of responsibility here, and we need to figure out what to do with that, maybe replace it with a more straightforward approach or something like that. So once we have identified the different risks, we have enough information to make an informed decision on what could be the best migration strategy for this application. So if we go up, we're presented with 6 R's. Or the 6 R's for Amazon, the standard for the different migration strategies to follow. In this case, we will choose refactor since we need to perform some changes in the source code for the application to be more container ready and cloud friendly, cloud native. I think removing the library is a small effort. If it's just about that, but there seems to be no other risk in the assessment. I know this application is very critical for you, and I think it should be our top priority to follow. So we can submit the review, and everything gets stored for later consumption. So now we have this assessment. We have some sort of clues of what needs to be addressed here. The next step will be to do an analysis and being able to detect on the actual source code what are the things that are preventing us from doing a clean migration towards cloud.
So we're going from kind of a high level disposition down into let's figure out what we need to actually change. Yeah.
Exactly. That's the idea behind this. So we have an analysis piece for Tackle on development right now. We're bringing some other project into the Tackle umbrella. So for the moment, we will have to switch to another tool. In the future, we want to have everything fully integrated in the same fashion like we have the assessment. So we click on application and click on assess. Well, it will be the same with the analysis. So for the moment, we need to switch to another application. And this is the analysis bit of it. The first step is to choose what is the migration path we want to follow. So I'm guessing you still want to keep the Tomcat runtime that you have right now for the application?
Yeah. I'll leave it like it is for now, I think, just to move forward quickly.
Okay, so no need to choose an application server. We need to do a containerization process, of course. I will do a sanity check with the Linux migration path just to make sure there are no Windows static paths in there from other versions of the application. And I know you have some problems with the licensing with the Oracle JDK, and you will want to get rid of that.
Yeah, that would be great if while we're moving, we could move to OpenJDK. It'd be wonderful.
So we choose that migration path as well. So we have containerization, Linux, and OpenJDK. So
maybe in the future we could actually use that Quarkus bit with our Spring Boot apps as well from Cloud Foundry.
Absolutely. Okay. If you want to do this modernization step, I think you already have used this somehow for these Quarkus applications you already have. So maybe your architects are somehow familiar with this.
Yeah.
So moving on, once we have selected the migration path we want to follow, then it's time to select which are the packages that we want to analyze. So we remove everything. We want to focus just on the business classes from your application and avoid the libraries. So we will choose this Konveyor packaging. It's funny because you use the same packaging that we do, so it kind of feels like this is some sort of staged marketing demo, but it isn't.
No, absolutely. The buildings behind me are real.
Okay, yeah, it looks like that. So once we have selected the business packages we want to analyze, we move on. Next step is the custom rules. So we've been discussing this custom configuration library. So we already had some conversations with your architects, and they already told us about this library. So we know how to find it within your code, and we already came up with some strategy to replace it with a more straightforward, standard approach to enable externalized configuration in Kubernetes.
So like something like config maps or things like that.
Exactly, being able to use config maps and secrets. So we need to sort this thing out within the source code itself to enable that possibility. So in order to detect the usage of this library in your source code, we have come up with a custom rule for the analysis bit. So I will upload the custom rule we developed jointly with your architects. So this analysis component is a rules engine that is extensible. So we came up with another extended rule, and we added to the rule set for the analysis. So we upload it, we enable the rule, and then we're good to go with the analysis.
Oh, great. Okay.
Moving on, we won't be using any custom labels. We also have a gazillion of options to further fine tune the analysis, but for the moment we will stick with the target.
Okay.
So moving on, and last step is to review that we didn't make any mistakes, which we didn't. So we're good to go and start the analysis.
Okay, so this is going to open up that application archive, look for any of those patterns that match, and then highlight them for me. Yeah.
Exactly. That's exactly what it does. It's some sort of static analysis using the binaries, decompiling, and then analyzing the source code. So since we are a bit tight in time, busy person, I already run the analysis beforehand, so I have the results here. These are the reports that are produced by the analysis. So we choose our application. The most interesting part of the analysis is the list of issues that have been detected. And by issues, we mean the things that are preventing your application to run on the target platform, which in this case is Kubernetes.
Okay. I see the legacy configuration, the hard-coded IPs, and the file system, and it caught all those, yeah?
Yeah, that's it, exactly. So this legacy configuration, that's an occurrence of the custom rule we developed. So it presents us the number of incidents within each one of the classes of your application and provides a series of hints and links to documentation on how to actually fix this issue. So if we click on the class itself, we can navigate straight into your source code and see where the offending lines have been detected on the analysis. And that this could be pretty useful to work with the changes, but we're working on a web console here, so we cannot actually do the changes.
Yeah. So how do my developers then actually go through and make this change? Can we refactor it?
Yes. So one thing could be keep changing from this window to your IDE, but that doesn't feel very productive to us. So that's why we developed a series of IDE plugins for the most popular IDEs out there. So my IDE of choice is VS Code, and I already have the project open in VS Code. I already installed the plugin. So once I have my project open, I can go into the plugin view and do the configuration of another analysis. So I chose the exact same target, migration target, which is cloud readiness, Linux, OpenJDK. I also use the custom rules. And once we're done with this, I can click here. I can click here and run, and the analysis will run, and we will get the results. So I already did that. I have the results in here. So we can access the exact same report that we have on the web console to be consumed locally. But again, we agreed that this is not the most practical approach to follow. So we also have a list of issues that have been detected on the application. So if we navigate towards this persistent config class and open it, there seems to be 2 hints. If I click on here, I can see what the offending lines are. If I need any more detail, I can hover here and see the description, or I can see the details. So I can basically get the details on what needs to be changed and the actual source code side by side, and start performing the changes, which could be pretty straightforward and easy. So after doing this, after doing all these changes, my application will be ready to be deployed in containers. But we need to go to the next level. Once we have our source code ready to be in containers, we definitely need to generate all the different manifests and images for this application to run in Kubernetes. And that is something that Move2Kube does. So we have my colleague Ashok here that will show you how this thing works.
Oh, wow, that's great. Thanks, Ramon. So basically, we've taken me through kind of assessing my entire application portfolio, then analyzing the customer app, then understanding what needs to be changed in it, making those changes. And now you're saying that we could use a tool called Move2Kube inside a Konveyor to actually generate all the objects and manifests and things I need to deploy on Kubernetes. Is that right?
That's it.
Okay, cool. So Ashok, from what I understood, you're going to focus on the Cloud Foundry pieces, but this could just as well, Move2Kube could be just as well used to create the manifests and objects for the customer's service. Is that right?
Absolutely, James. So as long as you have your source code or runtime information, Move2Kube can use that to create your destination artifacts.
Wow, that's great. That's great. Okay, so let's talk about my Spring Boot apps running on Cloud Foundry. How am I going to move those over?
Absolutely. So you have a couple of Spring Boot apps, the gateway service and the order services, and Node.js application, the front end. Let's look at them and see how we can translate them. Right. So let's have a quick demo of Move2Kube with the UI. Akash, if you can share your screen.
Sure.
Okay. So the first thing that we are going to do for Move2Kube is to look at the source code, right? So here is a source code of Move2Kube. We have the E2E demo apps. So let's look at what we have there. So if you look at the code there, you have the pattern-fried React seed, which is the front-end app. And then you have your back-end applications in the RH OAR microservices demo. You have your orders and the gateway services. So what we are going to do now is to take a zip of this folder. We have already zipped it in E2E demo apps.zip, and we are going to give it to Move2Kube to do the translation. So let's head over to the Move2Kube UI. So this is the Move2Kube UI. What we are going to first do is to create a project called demo, and then we are going to head over to that project. And the first thing we need to do is to upload the source code. So we upload the zip file.
Gotcha. So that's the source for my gateway and orders app and everything, actually, but gateway and orders too. Yeah.
Absolutely. Yes.
Okay. Great.
The second thing that we will be uploading is the configuration. So there are some environment information like your ingress and other information. We need to give it to Move2Kube so that it can create the exact right artifact. So we are uploading the configuration to Move2Kube, and you can see both of them there in the UI. The next step that we will do is to do the processing. Here, what it will do is it will go through all the files and use the configuration, try to understand what are the services there. So to save time, we have done a pre-processing of this in another project. So let's just head over to that.
Okay.
Okay. So now you can see that your plan file has been created, which has information on your different services and the different folders in which it found it, what are the configuration information about your applications. The next step that we will do is to use this information to do that transformation. So let's try that out. For that, let's click on Start Transformation. And then it uses the information in the plan file, the source code, the configs that we gave, and it will do the translation and give you the data.
Okay, so this is going to give me my artifacts that I need.
Exactly.
Okay.
So you can see that the transforming is done. There is. Let's download the artifacts and see what is that. So it will give us a zip file. Let's just unzip that file and see the artifacts MotoCube has created for us. So we are going to open the unzipped file in VS Code to look into the contents. So if you open the CF2 OCP folder, you have a source folder, which is your initial source that we uploaded, and into which it has seeded some more files. Let's look at what it has added to it. It has added the Docker files to each of your services.
Oh, great. So it created the Docker files for how to generate those services, yeah?
Exactly. So you can create your Docker images out of it using these Docker files. And then what it has also created is it has created some scripts which help you test locally. We have already used these scripts to build your images and push your images to registry. And the next step would be to deploy.
Okay, and under deploy is all my artifacts necessary to deploy on top of Kubernetes.
Exactly. So you can see your ingress, your deployment, the service, and all the YAMLs that you need to deploy for all your services.
Wow, yeah, that would save me a bunch of time. I mean, I would have to go do these all manually by hand for everything running on Cloud Foundry, yeah?
Exactly. And also, if you look at the YAMLs parameterized folder, it has a bunch of additional Helm charts, customized YAMLs, and OpenShift templates of these files. So if you prefer to use any of them, you can use that.
Cool.
Cool. Now, let's deploy this app into Kubernetes. So let's head over to our terminal, and let's check whether we are connected to the cluster by using kubectl version. Okay. So we are connected to the Kubernetes cluster. And then what we will do is we will now push the YAMLs. To do that, we will just do a kubectl apply. And we will give the YAMLs folder that we had.
Gotcha. So now you're just applying the YAML that was created by move to kube, and this should deploy our Cloud Foundry apps right on Kubernetes. Is that right?
That is correct. So we have already built the images, pushed the images, and now we have deployed all your services. It is creating all the deployment servers and ingress. Now let's look at whether all the pods are up, and then we can see our app running. So now that we can see all the
running, wow.
Yeah, all the pods are up. Now let's get the ingress and check whether the UI. So we have the ingress. Now let's just check the ingress in the UI. So let's hit here. And we are able to check, have your front-end app running with connections to your backend.
Wow, that's awesome. That's amazing. That automation really helps make things go a lot faster to be able to redeploy everything. Yeah.
Now you will be able to see locally, right? But you might want to automate your CI/CD pipelines. So if you notice, you have the CI/CD artifacts too created, the Tekton artifacts that you can use to automate your build process.
Nice. I could put those right into my pipelines and be on my way.
Absolutely.
Cool. Great. Thanks, Ashok. And Akash, this was really helpful to see how we could use move to kube to move our Spring Boot applications over. Let me go ahead and bring this back. So just to kind of reiterate where we're at. So we had just moved all of our Spring Boot apps over to Kubernetes now. So now I have my front end, my gateway, my order service, and my customer service all running on Kubernetes. But I do have a question here. We've kind of forgot about that database with the customer service. So how am I going to move that over? Miguel, you had mentioned moving that over with Forklift. Is that something we can talk through now?
Yeah, for sure. I mean, there are, as I said before, you may have like in this case a database or some other workloads that you would like to be able to move as they are into your Kubernetes environment. So let me share my screen and I'll show you.
Yeah. I'm definitely, I get it. I'm really nervous to move that over, do anything to it because there's a lot of old PL SQL in there. We don't really know what's going on. So getting it over onto Kubernetes first and then figuring that out would be a lot better.
Yeah, so we have this tool, Forklift, that is going to bring virtual machines from your environment, from your VMware environment into Kubernetes using KubeVirt. KubeVirt is a capability that helps you run VMs in pods, just like container in pods, but with VMs. So what we have here is that we have deployed Forklift and it has configured a provider that is KubeVirt, as you could see here. So we have source and target. So this is going to be the target. We need to add the source. We can simply add the source by adding VMware. And what we're going to do is just provide the name, the IP address or host name, and our credentials to access it, and a fingerprint to ensure that we're connected to the right place and there's no man-in-the-middle attacks. So right now we are adding this target. You see that VMware tab has shown here. And what we have right now, source and target providers, you see. And it has loaded everything. We can see here the host. So we have been scanning your VMware environment lively to get all the data. And right now we are ready to perform a migration. So to do that, we do a migration plan. And we create the plan and we give it a name. So we're going to focus on retail, is what we are migrating right now from what you told me. So let's migrate retail. And we select the source provider, in this case, vCenter, and the target provider, which is automatically configured and set at host, which is your Kubernetes environment. And we can select the namespace. I'm selecting here Globex Retail, although we can create it from the menu, and go next. And then I have to select the VMs that we want to migrate. So I select this cluster, and then it will gather all the information about the cluster. And I'll get here, you'll see all these VMs, and they're reviewed, so just in case they have something that will require some manual intervention. In this case, the name of the VM is not right, and we don't have change block tracking, so we cannot do warm migration.
Oh, that's really helpful. So it kind of guides you to tell you what to expect, right? Like you're going to have to make some changes to the name here, and you can't do a warm migration. Yeah. Okay, cool.
Exactly. We don't want to have issues during the migration. We want to warn as early as possible. So here we have the retail database that we want to migrate. And we have also some VMs like the business rules for bacteriological warfare and the ESB for doomsday. So these are for another day.
Yeah, we'll ignore those for now. Yeah.
We'll keep those out for now. So let's focus on the retail database. We click next. And now we have to establish an equivalence between the networks in the source and the networks in the target. So I'm going to create a map, an equivalence. So I'm going to use the VM network that the tool has detected in the VM that is being consumed by the network interface. And I select the target network. So I use the pod network, and I can save it to reuse it in the future. So I could save it as network map and go next. Same thing happens with the storage. We need to establish an equivalence between source and target storage. So it has detected that we are using an NFS data store in the source, and I'm going to use a standard. It's also NFS in the target, so they are equivalent. If you happen to need faster storage in the source, you should select also a storage class in the target that you have to have pre-configured in your environment first. So I could save it, click next. I am going to use cold migration because we don't have change block tracking, but there's the chance to be able to do warm migration, which copies the data before shutting down the VM. And once the data is copied, we could shut down the VM, copy only the changes that were applied to the disk, reducing the time required as downtime and increasing the number of VMs that you could migrate in one intervention window.
I like that.
Does that sound like helpful?
Yeah, absolutely. Less downtime is better.
Yeah. So we have also hooks in case we want to automate changes. We're not automating changes in this case. So we just complete and finish. and the plan is ready to start. So let's say that the intervention window arrives, we could click start, and the migration will start going on. So right now, the tool is connecting to the source, to VMware. It is using VDDK, which is what the backup tools use to gather the data. So if it works for backups, it works for the tool. And we are transferring the disk. As you're a very busy man, I already transferred one VM. So let me show you. I'm using here OpenShift, so we could show you in our UI. But all the tasks that I've shown you could be done via API or CLI on Kubernetes. So we are importing, and I have another VM already imported. So what I'm going to connect to this VM, okay? So I can connect to the console. And then, as you will see.
Oh, nice to see my Oracle database running on Kubernetes. It's great.
Yeah. It is exactly right there. If I do not mistype it, so I'm going to become the Oracle user, and I'm going to check for the connections, right? We have 200 connections, and we need more. We need 250. So that's one thing we could do in Kubernetes that is very interesting. We have this deployment, this config maps, okay? And I created a config map that is very small and straightforward. And what it does is that it changes the number of connections for me.
Oh, wow, okay.
So all I need to do, yeah.
So now my developers can make changes to this VM just straight through Git, right?
Yes, exactly. Wow. So I just go to environment, associate this config map. I have added one service to the VM to pass the config map. And the only thing I need to do is to go and restart the VM, and the changes will be applied.
Wow, that used to take us hours to get our DBAs to make changes and all that. So now you're saying it's just all pipeline based, right?
It's all pipeline based. It could be used as another Kubernetes object, the same way you would do it for a container. So,
awesome.
I mean, we could wait to check it, but the thing is that once the VM is started, we'll see that the number of I'll say connections has increased to 250. So this way is how we can move as many VMs as you want. Think that this tool is also intended to be able to migrate hundreds of VMs at once.
Oh, that's great. Awesome. Thanks, Miguel. This was super cool to see how we could, basically move this VM into more of a modern, modern way of working, right? How I can actually use it with config maps and make changes to it a lot easier. So,
yeah.
Cool. Let me just see. So just to kind of make sure I'm on track here. So we just moved that VM over, that Oracle database. So now we have the gateway, orders, and customer service, our front end, the Oracle database, everything running on Kubernetes, except for one last thing, Marco, which is my inventory service. So how am I going to do this? Remember, this was kind of manually deployed, and I need to figure out how I'm going to redeploy this into this new Kubernetes cluster, bring the state along, but also automate it with some kind of GitOps flow, because I don't want to leave it the way it is.
That's correct. And for that, we're going to use Crane. So just give me 1 second. I'm just going to share my screen, and I'll show you how Crane can help you with all that. So the first thing we want to do, right, like this was manually deployed in my inventory -source namespace, and now we want to be compliant with our production policies and have this automatically automated and following GitOps principles. So first thing I will do is to export the current manifest. So we'll use a command called crane export to do that. And what crane export will do is look at what's currently actually deployed in the inventory source namespace, export all the manifests. And then we can review those manifests and use another crane command, which is called crane transform, to actually clean this up, remove everything that is environment specific, and can do all kind of things to your files, so to actually or embrace even new technologies and things like that. So let me just wrong window. First show you this new export folder now that has all your Kubernetes manifests in there.
Okay.
And then I'll use the crane transform command, which will look at those and will be stripping out like service cluster IPs and metadata information that is specific to this environment.
So those are all the things that would trip me up when I'm trying to deploy to a new environment, right? Those are all specific.
Exactly. And that's a common mistake that we see, right? People are just like deploying something on one Kubernetes cluster, but like if you really want to embrace hybrid cloud and or even promote your apps from dev to QA to production, this needs to be automated, and you don't want anything to be hard-coded in there. So we want that to be programmatically done instead of like hard-coded in your manifest. But to do that, now we created like a transform folder, which actually is all the things we have detected that should not be hard-coded in your files. And we're creating JSON patches out of that so that this can be reviewed and analyzed to make sure, we're applying the right changes. And when we're ready, then we can use the crane apply command, which will look into all that, apply the patches, and then create all the files that you want to push to Git, so that at this point, this can be fully automated using Argo CD to deploy your app on any cluster, and can be done programmatically instead of manually as you're deploying or promoting your application. So let's just run the crane apply command. And now if I go to my Git folder, I have a resource folder that got created, which is the brand new manifest now fully cleaned up and ready to go. So the last step I have to do is to push that to my Git repository. So then Argo CD can pick this up and provision my application automatically for me. So if I go back to my main folder here, I have, if I can type, I have an Argo file now, which is the definition. Like, it's a very simple Argo definition that will actually, with the repository that I want to use to deploy this app, and the namespace where I want this to be provisioned from this point on. As soon as Argo is actually taking care of that for me, then I can make changes and push that to Git and have this automatically deployed all the time just through the Argo CD automated deployment model. But before I get Argo to do all that, this is our inventory service, and there's a lot of data as well, right? There's a database in there. There's a Postgres database with all your products.
Yeah, we have billions of products, billions.
So it's good that we're moving your application, and then we can deploy automatically. But there's a question of state, and the state is all the PVs, right? With all the data of your database that also needs to follow the deployment and be pushed from one environment to another. So we have another crane command for that is called crane transfer PVC, which use rsync in the background to actually copy the data. And this can be run multiple times. It will just copy the data from the last time I ran this command. But you guys have a big database with a lot of products, right? So I already ran that for you, so we don't have to wait for all those products or database content to be updated, right? So we'll save that for another day. But
yeah, as you can see in the warehouses behind me, they're filled with products. So
so I already ran that for you. The database is already there. So actually now I'm ready to run just in Argo. So I'm just gonna run this kubectl create with the Argo definition file. And this will launch Argo to actually provision my app. So let's look at Argo and see how actually Argo is provisioning all this. Just give me 1 second here. So you'll see now that Argo actually looked at my brand new manifest that we have created with Crane that is available on Git. And if I click on it, then you'll see like the full deployment of my application and attaching this to my PVs. With the database content.
So Crane basically has transformed all my objects, and then you push that into Git, and now Argo's just taking over and redeploying it. And now I don't have to, now my deployment's basically automated, yeah?
Yeah, and now you have following your GitOps principles that should be actually the best practices way of deploying apps and promoting apps and embracing hybrid cloud, as you can now deploy it on any cluster. And it would just follow along as everything is fully automated. So anytime you want to make a change, you make it on your Git repository, and then Argo would keep provisioning the latest changes for you automatically.
Great, awesome. Thank you so much, Marco. That's a great demo. Showing me now I believe. So this is basically the end state we've gotten to. So we've seen how we can now have all of our services running on Kubernetes, leveraging a GitOps paradigm, and then simplifying our operations by running on a single Kubernetes platform. So this puts our retail application in a great place. Right now we can start to plug in cloud services to this, start to bring in AI, ML, all the new cool things that are available when you're running your application natively on Kubernetes. So hopefully this demo by the Konveyor group was helpful, just to reiterate some of the tools you've seen across rehosting, replatforming, and refactoring. You can see them here. In the future, we're going to be bringing in Polaris as well, which will actually help us measure those DORA metrics, so that we could see the improvements we're making from a software delivery performance standpoint over time. So if you're interested in joining us on this journey, please join us at konveyor.io. This is where the community hangs out. We're interested in understanding how you're modernizing your apps and interested in building tools to rehost, replatform, and refactor your apps to run on Kubernetes and use other cloud native technologies. You can find us on Konveyor Slack. You can learn about us by joining meetups. And if you're interested in proposing a meetup talk, you can email us at konveyorio@gmail.com. So with that, I will go ahead and stop the recording, and thanks for joining us.